Today, we're going to talk about taking two polynomials and multiplying them. We've looked at adding polynomials together, we've looked at subtracting polynomials. Today we're going to look at multiplying. Specifically today, we're just going to look at multiplying binomials together. A binomial times another binomial. And the reason for it is there's a certain method that we use when it's a binomial times another binomial. If it was a trinomial or if it was a monomial or something different, we have to do a different way. And we'll do that in the next lesson. But for today's lesson, we're just going to look at a binomial, which is two terms, times another binomial, which is also two terms. Before we get into that, let's talk about just multiplying when it comes with exponents. So if I give you 4x to the second times 3x to the third, when we talked about adding and subtracting in the last lesson, we talked about how you can only add and subtract terms that have the same variable and the same exponent. So I could not add these together because this has an x to the second and this has an x to the third. However, you can multiply them. You can multiply whatever you want together. You can multiply an x by a y. You can multiply an a by a b. You can multiply an x to the second by an x to the third, or an x to the fifth times an x to the 100th. You can multiply whatever you want together, which is a little confusing because in adding and subtracting, you can only add and subtract numbers that have the same variable and the same exponent. But in multiplying, you can do anything you want. So if this was the problem, it's real simple. What we're going to do is this. We're going to take the coefficients and multiply them. 4 and 3, coefficients are the numbers in front of the variable, and we multiply them together. 4 times 3 is 12. Since they are both x's, we keep the x. But this time we're going to add the exponents together. You have to add the exponents together. So 2 and 3, we add them, make 5. So the answer is 12x to the fifth. We multiply the 4 and the 3. We keep the x. And 2 and 3 added together make 5. Let's look at another one. 5x to the sixth times 2x. We're going to multiply the 5 and the 2. That makes 10. We keep the x. And now we add the exponents. Now here's a 6, but there's not anything here. Remember, there's a 1. So 6 plus 1 is 7. So it would be 10. 5 times 2 is 10. 6 and 1 makes 7. So when multiplying, we multiply the coefficients and we add the exponents. Make sure we add the exponents. All right, so let's talk about the main purpose of this lesson, which is what happens when I multiply two binomials. Now, when I multiply two binomials, we're going to use a method which is called FOIL, the FOIL method. The FOIL method only works when you're multiplying a binomial times another binomial. Not when you're multiplying a trinomial, not when you're multiplying a polynomial, only when it's a binomial times another binomial can you do the FOIL method. Now, FOIL is an acronym, which means each of these letters stands for a word, so let's look at it. The F stands for first. First. You're going to multiply the first terms in each binomial. We'll look at examples of this in a second. The O stands for outside, so you're going to multiply the ones on the outside. The I stands for inside, the 2 on the inside. And the L stands for last. So here's FOIL. First, outside, inside, and last. That is an acronym. And that is the process, the order that we're going to multiply all of our terms when it's a binomial times a binomial. Remember, you can only do this when it's a binomial times a binomial. So let's look at a couple examples. 2x plus 3 times 4x plus 1. So this is a binomial times another binomial. And to do this, we are going to FOIL it. First, outside, inside, last. So the F stands for first. We're going to multiply the first term in each binomial. So the first term would be the 2x and the 4x. Those are the first terms. So we're going to multiply those together. 2x multiplied by 4x gives us 8x to the second. Because remember, we just talked about you multiply the coefficients, 2 and 4 make 8, and you add the exponents. There's a 1, and there's a 1, and 1 make 2. So we add the exponents. Now we do the O, the outside. Those are the 2 on the outside of the problem. You're going to multiply the 2 on the outside, which would be 2x and 1. Those are on the outside. They're on the outside of the problem. So we multiply those, 2x and 1, is 2x. Now the I stands for inside, so the two that are on the inside, which would be these two. So we multiply them. 3 times 4 is 12, and it's 12x, because that 4x has an x on it. L is the last ones, the ones that are last in both binomials, which would be 3 and 1. Those are at the last spot. They're in the last spot in each binomial. 3 times 1 is 3. First 2, outside 2, inside 2, last 2. And now we combine our like terms. Now 99% of the time, the like terms are going to be the 2 in the middle. Remember, the like terms are the ones that have the same variable and same exponent. And that's why 8x to the second is not a like term, because it has a 2 as an exponent, and these do not, even though they both have an x. So 8x to the second stays where it's at. These two I'm going to combine. When I say combine, we're talking about adding them. 2 plus 12 is 14. 2 and 12 make 14, and drop down to plus 3. Remember, as we talked about in the last lesson, in order for you to know it's your answer, it must be in order by degree from greatest to smallest, left to right, and we cannot have any like terms. I have no more like terms, and this is degree of 2, degree of 1, degree of 0. So it is in order by degree. That is the FOIL method. First, outside, inside, last. Next example says 4x minus 5 times the quantity x minus 2. So if we FOIL, first, the first ones, 4x times x is 4x to the second. Because remember, 1 and 1 add up to 2. Outside, the ones on the outside of the problem, 4x and negative 2, 4 times negative 2 is negative 8x. Now the ones on the inside will be this one and this one. Negative 5 times x is negative 5x. And last, the last ones. So negative 5 and negative 2. Remember, that's a negative 5 and that's a negative 2. Negative 5 times negative 2 is a positive 10. First, outside, inside, and last. Now we combine our like terms. As I said on the last example, those will typically be the 2 in the middle. 4x to the second comes down because there are no other x to the seconds. There's no like terms. Negative 8 and negative 5 is negative 13 plus 10. There are no more like terms, and it is in order by degree, so this is my final answer. Let's do one more. The quantity 3x plus 10 quantity squared. All right, now this looks different, but it's just actually written in a shorter way, and it's written with an exponent. Hopefully we remember that what is an exponent? 4 to the second is actually saying take this base times itself 2 times. So it would be 4 times 4, right? It's not 4 times 2. It's 4 times itself 2 times. If it was to the third power, then it would just be a third time. Same thing here. It is to the second power. So all it is saying is I'm going to take the base, which in this case is 3x plus 10, and I'm going to multiply it by itself 2 times. So if you ever see that, all you need to do is write it out 2 times, and we're going to multiply it twice. And now we FOIL it, because it's a binomial times a binomial. Well, in FOIL, we have our first 3x times 3x. That is 9x to the second, because x and x, add them up, make 2. Then I do O, the outside, which is 3x times 10. Outside are the ones on the outside. 3 times 10 is 30. Then I do the inside, which is 10 and 3. Once again, 10 and 3 make 30. And L stands for last, the ones that are last. 10 and 10 make 100. So first, outside, inside, last. The first ones, the outside ones, the inside ones, and the last. Now we combine our like terms. Once again, those are the ones in the middle. 9x to the second plus 60x, 30 and 30 makes 60, plus 100. There are normal like terms, and all my degrees are in order from greatest down to smallest. That is multiplying a binomial times another binomial. To do that, we use the FOIL method. The next lesson we're going to look at is multiplying other types of polynomials, which we have to use a different method besides FOIL.